A tsunami that sent a giant wall of water racing towards the coast.
A sudden explosion.
March 11, 2011, began like any other Friday in Japan. But in just 6 minutes, the physical structure of our planet permanently changed. The Earth's crust ruptured with such violent force that Japan's main island of Honshu was physically pushed nearly 8 feet to the east. Entire sections of the eastern coastline sank 3 feet deeper into the sea. The sheer mass displacement was so massive it shortened the length of Earth's day by 1.8 microseconds and tilted the planet on its axis by nearly 7 inches. It started as a magnitude 9.1 megathrust earthquake, the most powerful ever recorded in Japan's history. But the shaking was merely a trigger. What followed was an unstoppable chain reaction. A sea-wall-shattering wall of ocean moving at the speed of a jet airliner, a multi-reactor nuclear meltdown, and a terrifying reality where the living were completely overwhelmed by the sheer volume of the dead. This is the full, minute-by-minute account of the deadliest 24 hours in modern Japanese history, and the harrowing sequence of events that brought the world to the edge of an unprecedented global disaster. The story of March 11 actually begins 48 hours earlier. On March 9 at 11:45 a.m., a magnitude 7.2 earthquake struck off the coast of Sanriku. In a country that experiences over 1,500 tremors a year, citizens brushed it off as routine. 3 more quakes exceeding magnitude 6.0 hit the exact same zone that day. Life quickly resumed. No one realized these were foreshocks, the Earth exhalations before a massive geological rupture. Then came Friday afternoon, 2:45 p.m. Deep beneath the ocean floor where the Pacific tectonic plate slides under the Okhotsk plate, centuries of built-up strain finally snapped. Over 1,000 ultra-sensitive seismometers across Japan detected the initial, non-destructive P waves. Within milliseconds, Japan's automated early warning system activated. Overhead power grids cut safely, high-speed Shinkansen bullet trains slammed on emergency brakes from 180 miles per hour without a single derailment, heavy factory machinery ground to a halt, and millions of school children ducked beneath their desks. The technology worked flawlessly. But no engineering on Earth could mitigate what hit 1 minute later. At 2:46 p.m., the primary S-waves hit the surface. For 6 agonizing minutes, the Earth churned. The epicenter was located 45 miles east of the Oshika Peninsula at a shallow depth of 18 miles. Kurihara City in Miyagi Prefecture hit a maximum 7 on the Japanese seismic intensity scale, a level where human beings cannot remain standing and concrete structures flex to their limits. Over 230 miles away in Tokyo, skyscrapers swayed violently like reeds in the wind for several minutes. Shaking was recorded across China, Russia, Taiwan, and on instruments worldwide. Nearly 200 people were killed by falling debris and structural collapses from the quake alone. Oil refineries, like the Cosmo oil facility in Chiba, burst into flames that burned uncontrollably for days. Yet as the shaking finally subsided, survivors stepped into the streets believing the danger was passing. They had no idea the real killer was already racing across the ocean floor. When the fault line ruptured, it forced a 300-mile stretch of the ocean floor upward by as much as 30 feet, displacing trillions of gallons of water. At 2:49 p.m., the Japan Meteorological Agency issued its initial tsunami warning, predicting wave heights of up to 20 feet. Minutes later, offshore deep ocean GPS buoys registered a terrifying reality. The sea was rising far faster and higher than computer models had ever calculated. JMA immediately upgraded the warnings to over 33 feet. It was not a standard cresting wave, it was a rising, continuous wall of dense, black seawater pushing inland at up to 500 miles per hour in deep water, and slowing to 20 to 30 miles per hour near the coast while building massive vertical height. Between 3:15 p.m. and 3:35 p.m., the ocean struck a 420-mile stretch of eastern coastline. In Miyako, the deep, V-shaped geography of the Sanriku-ria coast funneled the incoming water, forcing it upward to a staggering peak height of 131 feet, the highest tsunami run-up ever recorded in Japanese history. Decades of protective civil engineering were rendered useless. Massive concrete seawalls designed after historical disasters in 1933 and 1960 were completely overtopped or pulverized by the raw tonnage of the sea. Because the earthquake had caused the coastal land to subside by up to 3 feet, the effective height of every seawall was reduced before the water even arrived. In towns like Rikuzentata, Kameishi, and Keisenuma, 3-story buildings were submerged entirely. The water tore houses off their foundations, carrying thousands of structures, shipping containers, burning oil tanks, and vehicles inland like battering rams. At the Noeru school building, 74 out of 108 students and staff lost their lives when floodwaters breached what was supposed to be a safe shelter point. When the water finally began receding 30 minutes later, the outward undertow was just as destructive, dragging millions of tons of debris, infrastructure, and thousands of victims straight out into the Pacific Ocean. Over 18,000 people died or went missing in less than an hour. Morgues were overwhelmed immediately, and local authorities ran out of dry ice, coffins, and basic supplies to handle the sheer volume of casualties. While search and rescue operations struggled to begin in the destroyed coastal regions, a far more dangerous catastrophe was unfolding 100 miles away at the Fukushima Daiichi nuclear power plant in Okuma. When the earthquake struck at 2:46 p.m., Units 1, 2, and 3 were actively operating. The plant's safety systems performed as designed. Automatic control rods inserted into the core cores to shut down the fission process, a procedure known as a scram. However, shut-down nuclear fuel continues to generate significant decay heat and requires constant active cooling water circulation to prevent overheating. The earthquake destroyed the off-site electrical grid supply to the plant. Right on cue, 12 emergency diesel generators located in the basements automatically fired up, keeping the coolant pumps running. For 55 minutes, the plant was stable. At 3:35 p.m., the second wave of the tsunami slammed into Fukushima Daiichi. The plant's seawall had been built to a height of only 19 feet. The incoming tsunami wave exceeded 49 feet. Millions of gallons of ocean water flooded over the seawall, drowning the low-lying turbine buildings and filling the basements. The emergency diesel generators were submerged and destroyed. Electrical switchgear was ruined. By 3:54 p.m., Fukushima Daiichi experienced a complete station blackout, SBO. The facility lost all AC power. The control rooms went dark. All primary cooling systems shut down simultaneously. Without power to circulate water, the temperature and pressure inside the reactor vessels soared. Water surrounding the superheated nuclear fuel rods began to boil away, exposing the zircular metal cladding of the fuel assemblies. At extreme temperatures, zirconium reacts with high-temperature steam to produce vast quantities of volatile hydrogen gas. At 7:30 p.m., the Japanese government declared a nuclear emergency, ordering an initial evacuation within a 1.9-mile radius. As internal reactor temperatures breached critical thresholds, nuclear meltdowns began in Units 1, 2, and 3. On the afternoon of Saturday, March 12, at 3:36 p.m., hydrogen gas accumulated in the upper structure of Unit 1 and triggered a massive chemical explosion. The blast tore off the reinforced roof and walls of the reactor building, releasing dense plumes of radioactive material into the atmosphere. The evacuation zone was expanded to 12 miles. Specialists fought round the clock under pitch-black conditions, high radiation fields, and constant seismic aftershocks, attempting to pump seawater directly into the reactor cores using fire engines as a last resort cooling effort. It was not enough. On March 14 at 11:01 a.m., a second, even more violent hydrogen explosion ripped through Unit 3, injuring workers and damaging nearby equipment. On March 15, Unit 2 suffered internal damage, releasing massive radiation spikes, while a fire broke out in the spent fuel pool area of Unit 4. Ambient radiation levels inside the plant surged to over 1,000 times normal limits. With conditions turning lethal, non-essential personnel were evacuated. A core team of roughly 50 workers, later dubbed the Fukushima 50, voluntarily remained behind inside the heavily contaminated site. Comprising veteran technicians, engineers, and first responders from TEPCO and emergency services, these men navigated dark, radioactive debris fields to manually operate valves, lay temporary power lines, and continuously vent containment structures. Their actions prevented a full structural containment failure across all units, which would have released catastrophic quantities of radioactive fallout across eastern Japan and Tokyo. The impact of March 11 did not end on the shores of Japan. The tsunami crossed the Pacific Ocean at speeds exceeding 500 miles per hour. Within hours, 12-foot waves hit Hawaii and the Aleutian Islands. In Crescent City, California, and Santa Cruz, the surge destroyed harbors and crushed dozens of vessels, causing tens of millions of dollars in damage. 18 hours after the initial quake, a foot-high wave reached Antarctica, snapping massive ice chunks off the Salzburger ice shelf. Radioactive isotopes from Fukushima, primarily iodine-131 and cesium-137, were carried eastward by atmospheric jet streams, reaching tiny detectable levels in western North America and Europe within days. Over 10,000 tons of radioactively contaminated water eventually leaked or was intentionally released into the Pacific Ocean to manage storage limits, sparking long-term environmental concerns across the Pacific Rim. Over 150,000 residents were displaced from the Fukushima exclusion zone. More than 120,000 buildings were completely destroyed, with another million structures damaged. The World Bank estimated the total economic cost at $235 billion, officially designating the 2011 Tohoku disaster as the most expensive natural disaster in human history. March 11th stands as a permanent historical marker. It revealed how a triple disaster, a megathrust earthquake, an unprecedented tsunami, and a multi-reactor technological crisis, can simultaneously test the absolute limits of human infrastructure, disaster preparedness, and heroic resilience.